Hey guys, how we doing today? We're going to go ahead and start off doing lesson 3.1. And this is going to be understand and represent exponents. All right, so we're going to start off by talking about what is an exponent, or what does that look like. An example of this could look like this. We have two parts to an exponent. We have the base, then we have the actual exponent. So we have the base, which is the larger number, and the exponent's the number in the top right-hand corner that's a little bit smaller. Let's go and define what both of these are. So we'll skip down here, put a little bullet, write the word base. And the base is the number that is repeatedly multiplied. All right, so the base is the number that is repeatedly multiplied. Skip down here, and we'll have the next word, which is exponent. And the exponent tells how many times the base is used as a factor. So the exponent tells how many times the base is used as a factor. So again, one way I like to think about it is the base, even though it's bigger, this is the exponent's kind of like the bossy sibling. It's smaller, but it tells the base what to do. So it's telling the base that it's going to be repeatedly multiplied 3 times. It tells how many times the base is used as a factor. And we do know from math that factors are two numbers that are multiplied together, 2 or more numbers. To expand this a little bit, a lot of times in our book, you're going to see this word, the words evaluate. And I know you've heard that word and we've talked about it before, but they'll definitely be using this word a lot more in these coming topics. And evaluate just means to find a value. Could be to find the value of an expression or to find the value of the actual exponent. But again, it's just wants you to find the value. So let's go ahead and backtrack a little bit, and we're going to go ahead and use this example to kind of show how exponents work. So if I have 2 to the third, and we were asked to evaluate it, all this means is that we're going to multiply the base by itself 3 times. So that means 2 times 2 times 2. Remember, do not, and I repeat, do not just think this means 2 times 3, because that's not saying that it's multiplying itself 2 times, or excuse me, 3 times. So we want it actually multiplying by itself 3 times. 2 times 2 times 2. So we'll break this down. We'll start with the first 2. 2 times 2 is 4. And we'll multiply it by the last 2. 4 times 2 is 8. It's pretty simple. Sometimes you'll see it looking like this. Other times you'll see it, or they'll write about it and refer it to as something called a power. So sometimes it's called 2 to the third power. but you would have the exact same value. And the value of this would still be 8. Now again, I don't expect you to do this in your head, especially when the numbers start to get a little bit larger. Make sure that you are actually writing this down. Don't try and skip these steps. So especially if you're getting to larger exponents, to the 5th, to the 6th, it makes no sense to try and do that all in your head. Write it down or chunk it up into little sections like this. You guys started learning about exponents back in 5th grade. When we did it in 5th grade, though, it was more base 10 systems. So base 10 systems were anything with 1s and 0s. So for example, you should be familiar with something that looks like this, 10 to the 4th. 10 to the 4th is the exact same thing as what we did up here. So it means 10 multiplied by itself 4 times. So it's 10 times 10 times 10 times 10. Now, the great thing about doing it with base 10 systems is that we don't have to write this out in a multiplication format and do, all right, 10 times 10 is 100. All right, 100 times 10 is 1,000. All right, 1,000 times 10 is 10,000. We don't have to write this all out. We can easily do it by writing down our 1, and this exponent tells us how many zeros we have to add on there. So because I'm dealing with base 10, I can just add zeros. So since it's 4, I can add 1, 2, 3, and 4 zeros. Then I'll go back through and put my comma, 1, 2, 3, comma, and get the answer of 10,000. Again, we don't have to do the same thing we'd have to do when we're dealing with non-base 10 numbers, because again, zeros are very easy to work with. So let's go and turn the page, and we're going to do a couple examples here. So right at the top of the page, I'm going to go ahead and write down examples. I'll show you what a couple of different varieties of this could look like. So very first one would be when we choose 8 to the 3rd. So again, if you're paying attention, this just tells us that we need to multiply 8 by itself 3 times. So it'll be 8 times 8 times 8. So again, we'll take little bites out of this, and we're not going to try and do the thing all at once. So let's start with the first 2 factors, 8 times 8. So because we know our basic fact, 8 times 8 is 64. And we know we now have to multiply by this other 8. 64 times 8. I can't do that in my head. So on the side of my paper, I'm going to write 64 times 8 and be able to solve this through. Just for sake of space here, I already did it. So 64 times 8 is 512. Again, we don't try and do this in our heads. Right? We write this on the side of our paper and solve for it. So that's about as basic as this one gets. Now, because we're in 6th grade, we don't just deal with whole numbers. We deal with fractions and decimals. So another way this could look could be with a fraction. So we'll do 1/5 to the 4th. So nothing has changed. Just because it's a fraction doesn't mean that we do something different. We're just going to do the exact same thing we did over here with 8, but this time we're going to use 1/5. So we'll write it down. Do 1/5 times 1/5 times 1/5 times 1/5. So it just means 1/5 4 times. So again, we'll start by chunking this up. We'll start with the first 2 factors, 1/5 times 1/5, and we know, because we've already studied multiplying fractions, we multiply straight across, numerators times numerators, denominators times denominators. So 1 times 1 is 1. 5 times 5 is 25. Let's do the same thing to these 2. So we'll multiply the numerators. 1 times 1 is 1. 5 times 5 is 25. Now we'll multiply these last 2 factors 1/25 times 1/25. The numerators are easy. 1 times 1 is 1. Then 25 times 25, same thing as this problem over here. We're going to write that on the side of our paper, and we're going to multiply 25 times 25, and we'll get 625. Again, the process of this is not difficult, but you're going to have to make sure you're taking your time when you are doing your work on the side of your paper to be able to multiply 25 times 25. Use all your basic math skills to be able to do that. Again, like I said, the process is not hard, but your multiplication and your long multiplication is going to take a little bit of work. So here's two different ways it could look. Now, you're going to come across another type of problem that's going to look just a little bit different. And an example of that will be 58 to the 0 power. Now, you're probably thinking, oh, 58 to 0 power, that's 0, right? Well, not exactly. 58 to 0 power, anything to the 0 power, except for 0, so any non-zero number, is always, always, always going to be 1. And we're going to make a little note of that right below that, just so we don't forget that. It's any non-zero number raised to an exponent of 0 has a value of 1. So any non-zero number raised to an exponent of 0 has a value of 1. So it doesn't matter if it's 58 to the 0 power, which equals 1, or maybe it's 1/5 to the 0 power, that's going to equal 1, or if it's 2.7 to the 0 power, it's always going to equal 1, just as long as it's not a 0. If it's 0 to the 0 power, that's going to be undefined. Now we have one more example. Because we're in 6th grade, we're not going to have just simple problems like this where we're just doing our basic multiplication. We're going to actually have expressions. An example of what an expression could look like would be this. We'll use a decimal this time. 6 2/10 times 10 to the 3rd. So again, we want to kind of break this into steps here. So I know that I want to turn this into a usable number. 10 to the 3rd is kind of hard to work with. So I want to turn this into just a whole number. So because this is base 10, this one's going to be pretty easy for us. So we'll start by rewriting 6 2/10, bring that down. And now we're going to change 10 to the 3rd power, and we're going to change that to a whole number. So that just means I could solve it by doing 10 times 10 times 10, or I can just write down my 1 and add 3 zeros. And I'll do 1, 2, 3, comma. So this is just telling us 6 2/10 times 1,000. Now the great thing about multiplying by base 10 is whenever we have a decimal, we don't have to write this out in long division format. We don't need to write 6.2 times 1,000 and go through all the steps. We can simply write down 6 2/10, and we know, if you're multiplying by base 10, if I'm multiplying, I just have to move the decimal to the right, however many zeros there are. Since there's 3 zeros, how many times am I going to move that? 3 times. So I'll put my pencil on that decimal, and I go once, twice, 3 times, and I put my new decimal, I X out my old one, and if I have any loops with no digits, I'll fill those in with zeros. And then right underneath this, I'll rewrite it because that's kind of sloppy and hard to understand. So I'll write down 6, 2, 0, 0, and then I'll put my comma. 1, 2, 3, comma. So 6,200. So again, 6 2/10 times 10 to the 3rd equals 6,200. So again, boys and girls, the biggest thing that I can say about using exponents is don't skip steps. Take your time, go through everything. Don't do everything in your head. Try and break it down into steps, just like I've done here, like I've done here or here. Don't do it in your head. Take your time and write down what you're actually going to be multiplying. So again, I hope this helps, guys, and have a great day.